I'm M. Narasimhavardhan, and it is my pleasure to be a host for this evening. Extramural Lectures is a platform for students of IIT Madras to interact with distinguished personalities from across the globe from diverse fields. We envision to serve as a platform to promote knowledge in a multitude of domains and create a free atmosphere of open-ended exchange of intellectual thoughts. To this end, we are driven to host eminent personalities as well as individuals who have shown great initiative towards driving forward change. Our distinguished guest for today is Dr. Chandrasekaran Mohan. Sri Chandrasekaran Mohan is an alumnus of IIT Madras of the batch of 1977 from the Chemical Engineering Department. He received his PhD in Computer Science from the University of Texas, after which he joined the birthplace of relational databases and SQL, namely IBM Research in San Jose, as a research staff member, and worked on projects like R, Starburst, Exotica, and DB Cache. 15 years later, he was named an IBM Fellow, IBM's highest technical position, for being recognized worldwide as a leading innovator in transaction management. During June 1998 to July 1999, while being on an IBM sabbatical, he worked as a visiting scientist at France's premier Computer Science Research Institute, INRIA, Rocancourt, in the suburbs of Paris. He also worked as the IBM India Chief Scientist based in Bangalore from 2006 to 2009. In 2016, Mohan was named a distinguished visiting professor of China's prestigious Tsinghua University. Mr. Mohan has published numerous conference and journal papers in the areas of database workflow and transaction management. His journal papers on Aries and Presumed Abort are considered as the classic papers in the areas of transaction, recovery, distributed commit and locking, and are included in a collection of database papers called the Red Book. Currently, he is a steering council member of IBM's Software Group Architecture Board and a member of IBM's Technical Leadership Team, IBM Academy of Technology, and Information Management Architecture Board. He often talks about the importance of long-term technical careers with sustained focus in one area to attain excellence and to be effective in innovation, and he is the living example for it. He stayed as a technologist during his entire 34-year professional career. Sir, it's a privilege to have you here with us today. May I request the student head of EML team, Sai Bharadwaj, to welcome the chief guest on our behalf. I would now like to invite Dr. C. Mohan to address the audience.
It gives me great pleasure to be here. As you heard, I think I graduated, 42 years ago, and I see at least one of my classmates there. I don't know whether there are more guys here. Vishwanathan sitting here. So 1977 is when I got out of here with a chemical engineering degree, but then I was more interested in computer science than chemical at the time. Oh, thank you. Is it working? Oh, good. Thank you. So I'm not by any means an expert in AI at all, but I've started giving these talks somewhat recently. So I might or might not be able to answer all the questions you have, but what the heck, I'll give it a shot. So I decided, with too much emphasis these days on AI being equated to deep learning, a bit of the history will also be a useful thing for you guys to hear about what all topics have been covered under the AI umbrella and how things have changed over the decades, and what are some of the important conferences and people who have done work in this space. So this is going to be a fairly high level talk. The intent was not to go into the gory details of some specific algorithms and so on. But my own background, in case it wasn't obvious from what was said, is more in the hardcore database area. My lab is where the IBM Almaden Research Center, as it's called now, it used to be called the San Jose Research Lab, is where relational databases and SQL came from. Ted Cott, the father of relational, was there even 38 years ago when I joined. A couple of years later, he retired. Hard disk drives came from my lab, and even atoms being manipulated one at a time, kind of really far out technology using the scanning tunneling microscope, which itself was invented in Zurich, IBM's research lab, but was used for the first time in my lab to manipulate atoms individually, lift an atom and drop it somewhere and that kind of thing. So this lab in that sense is an extremely well-known place for all sorts of very practical to very esoteric kind of work being done, and hard disk drives and even optical devices work used to be done. Even though these days IBM is not in that business anymore, but the research still goes on. Anyway, let me go on with the talk instead of giving you all the background about what happens in my research lab and things like that. So, just to make especially the people who are not necessarily AI people know about what the real story is. Deep learning is just one aspect of AI. There are other things that are part of AI, but not enough people think about it that way these days with all the hoopla surrounding deep learning. It's also the case that essentially AI is code. So wherever software is, you could actually benefit from the leveraging of AI technologies. In particular, for example, even in database systems, internally, AI-oriented ideas are being leveraged to make database systems be more self-organizing, not hardwire certain things like cost models and so on, and also make the system be more adaptable to changes in workloads and such things. So that has also become a big area of focus for people who might not themselves be thinking of their work as AI-ish work, but they want to benefit from the leveraging of AI technology that somebody else might be developing in the context of whatever it is that they are doing, which might still be a computer science kind of topic, not necessarily, leveraging it for healthcare or this or that, which are like higher level, domain-specific kind of application areas. So in terms of people that have received the highest honor you can get in terms of awards in computer science field, which is the Turing Award, that's typically given to a small number of people each year. These are the people who have, over the decades, received the Turing Award. And I put the citations also, and also the institutions that these people belong to. So some of you might be noticing that there is one Indian name there. That's Raj Reddy. And by the way, he's the only Indian who has ever received a Turing Award. This is only the AI-oriented Turing Awards, right? But even outside of AI, no other Indian has got the Turing Award. And you will see that the latest award also went to people who have done work, even though the citation doesn't explicitly say AI, it is for the deep learning work that has taken over the world like crazy in the last number of years. And interestingly enough, for those of you that might or might not know it, one of the guys that's an IIT Madras alumnus who is now leading work in Facebook on the more practical side as opposed to Jan LeCun, who is also part-time Facebook guy, but he's also in NYU, is Srinivas Narayan. He is in the Bay Area, in my backyard, working on the topic of AI. Has he been here? Okay. Okay. But I most recently heard him speak a few weeks ago as part of the at-scale conference, and it was quite a phenomenal set of stuff that he talked about. And companies like Facebook and so on, they have access to so much data about usage patterns and all sorts of things, images and video and such things, that it's totally like in a different space in terms of the scale at which the algorithms that they dream up need to work. And so it's not like some university thing, or even in some commercial establishments where the scale might not be anywhere as big as one of these Web 2.0 kind of companies is dealing with, that you don't have to, work with artificial data and things like that, or synthetic data, as some of you, even in IIT Madras, might be working if you don't have access to real-world data. So it's interesting that, Marvin Minsky, whose name came up in a different context in the recent past, at MIT had worked on it very early on. And so from '69, they've been giving out these AI-oriented Turing Awards. And in terms of the topics that were focused by, for example, Raj Reddy kind of people at to do with speech understanding, robotics, expert systems. Even when I was an undergrad here, some of these things were already being worked on at SRI and places like that. Stanford Research Institute, which originally was like an appendage to Stanford University, but then it became an independent entity. And so they used to focus on even health-oriented topics or assistance to doctors and so on, mycin and such systems. So what I got to hear in a short span of time between November 2017 and April 2018 were talks given by first Raj Reddy in Shanghai and then Ed Feigenbaum at the Stanford Computer Forum. And those two talks wound up being very interesting, and I'm going to use some of the slides from Raj's talk. They essentially gave like a retrospective kind of view of how AI has evolved since the time back in 94 and even before that, 94 being the time when they got the Turing Award, to sort of today. And so what Ed Feigenbaum did was to use the fact that the Computer History Museum in our area, which had produced a film on AI, he decided to sort of critique that film and in that process talk about what all they covered and what they left out in this historical view of AI. So it turns out the birth of AI is, after the fact, attributed to a particular workshop that happened to be held in Dartmouth University in the summer of 1956. Essentially, I was 1 year old at the time this happened, and that's, in retrospect, thought of as the birth of the concept of AI, okay? It turned out later, a good number of the people who participated in that workshop wound up becoming the leading lights of AI, okay? Originally, like the first decade of AI, think of from the mid-50s to mid-60s, the focus was on heuristic search for problem solving, syntactic computational linguistics, checker playing programs, and so on. And later, of course, knowledge-based systems and expert systems where you codify the rules that determine when somebody should get a loan or what are the steps that you should go through as you try to diagnose based on symptoms what the disease might be. The thinking process that the human might go through gets codified in terms of these rules, and these expert systems might have multiple rules that might fire, and there were all sorts of geeky things that you had to worry about potentially sometimes conflicting rule firings and things like that. But also, in the process of trying to do all this, even speech understanding and such things, the question was, do you do it based purely on the phonetic sounds that you are hearing and trying to recognize what the words might be? Or do you use the grammatical structure of the language, whether it's English or Hindi or whatever the language is? Do you also take into account the semantics, not just the syntax of the language, but to also try to figure out in the ambiguous situations where the person's pronunciation might not be the accurate pronunciation that someone declares to be the right way of saying something and so on. Can you now, based on making use of these different aspects, syntax, semantics, and phonetics and so on, figure out the correct way to interpret what the person said is? If you don't need to necessarily involve the human to get clarification, also the information about the world at large, that let's say that a tiger is an animal, so is a lion. These kinds of general knowledge, how do you codify it so that programs can make use of it? This is what this sense knowledge representation, there was a project called Psych that I believe started originally in Stanford, and then Doug Lennett, I think, moved to MCC, Microelectronics Corporation, that was started as a consortium in Austin, Texas, by a number of US companies. There he continued working on this way of trying to take the world knowledge about day-to-day things and put it in a form that machines can process it. A lot of these sorts of things are needed if you really want to do a far better job of trying to understand as opposed to just recognize in a very pattern matching way. You'll find that these days, this deep learning way of doing things a lot of times doesn't involve this level of sophistication, but in a brute force way, it tries to do things without domain specific aspects of the problem that's being dealt with being taken into account, which you will hear people saying requires a lot more manpower and time consuming and so on. So people think these days that, oh, this deep learning approach, as long as you have enough data to train the software, is a far better, more effective way of doing things from a cost perspective and so on. But it turns out it doesn't always work. There are many cases where not taking into account domain-specific aspects of the problem leads to, you would have seen some examples of a muffin being mistaken for an animal and things like that just because there's some similarity. Or if the algorithms have been developed in the context of people of certain ethnicity, and then when you apply it to people of different ethnicity, there's this, I think, a particular example where a black person was recognized as a bear because this algorithm had been trained with only white people related images and so on. So things like that are the sorts of problems that you won't necessarily hear about when somebody is hyping a certain aspect of, let's say, AI and how deep learning has made a huge difference. So anyway, I also felt, unlike maybe some other presentations where people tend to talk about deeply technical things, also hearing a little bit about how the focus in an important conference in the AI space has changed over time and how certain things are still being talked about. So one of the major conferences in AI, before it became further subdivided into various narrower aspects and separate conferences for each narrower aspect came about, is this IIT conference, International Joint Conference on AI. So the first one was held in 1969, right? And those were the topics, the major session topics in that conference. Later I'll show you how in the latest conference, the topics, some of them look similar and some are like things that were not in this original list. As you can see here, it was all over the place. Pattern recognition, pictorial representation of information, signal processing. So some of that speech understanding thing that I was talking about, phonetics and so on, they were more analyzing the signals and trying to see how much that alone will help in speech understanding versus then taking into account syntax and semantics and so on. And also linguistic research, natural language understanding, things like that, right? Heuristic problem solving, programming systems and mode for artificial intelligence, even theorem proving. How do you make the system? In fact, I went to school at UT Austin. One of the two people there, this is Boyer and Moore, they got their Turing Award for theorem proving, right? So there were various things like that that people have worked on since those days. So this now is a slide from Raj Reddy's talk in Shanghai. So he made this point that when he was seriously working on these things, and he's still working on deeply technical things, even though he's quite an elderly person now, he had thought that certain problems will not get solved in his lifetime. But then now he is discovering, in the last decade or so, that some of those problems at least have been actually solved. So he was trying to rationalize what made a difference in some of those things that he didn't think will get solved in his lifetime did get solved. And that's where he said things like big data, the availability of vast amounts of data to train the algorithms and such, which he didn't think would be there by the time he leaves Earth, as well as some of the hardware developments are the things that have made a difference, in addition to, of course, algorithmic improvements and so on. So there are three aspects to this whole thing. One is the compute power available, the other one is the algorithms, and the third one is the availability of training data, so that humans don't have to worry as much about building the intelligence into the algorithm itself. It can be a self-organizing kind of system and so on. So of course, describing all this, he was talking about how in the era of AI 1.0, which was the initial, let's say, a couple of decades or whatever, compared to now when we talk about AI 2.0, what are the different things that people have focused on. So he talked about how, exhaustive search way of being able to look at different ways of, let's say, making the system play chess or various games like that, versus areas where unless you have knowledge that comes from elsewhere, like E equals MC square, which cannot be in an exhaustive search way figured out. Some invention is needed. So knowledge compensates for lack of search in such cases where somebody invents these relationships. Exactly how that comes about is a different discussion, right? It's not based on any exhaustive analysis and such. Whereas things like solving puzzles are based on more, in a brute force way, trying different possibilities. And as a human, you might not be able to do all this in your head. There are some humans, of course, that can do, more of the figuring out things in their head kind of way of looking at the different possibilities. But machines are much more capable in this space because of parallelism and all sorts of functionality that's there. And also there's this, what are the sources of knowledge? Where does knowledge come from? What you learn versus what you experience in life and that sort of thing. And how do you codify all this knowledge through rules? Oh, careful. Knowledge-based systems, rule-based systems and such. So there have been since then, since the initial times of AI, various projects that have happened. Raj and other people at Carnegie Mellon are well known for not only the speech understanding work, but also the Robotics Institute at CMU is a very well known institution with a long track record. But unlike what some of you might be thinking, that all these self-driving cars and all that are like a very modern phenomenon, that's not true actually. A couple of decades ago, or even earlier than that, the US government had these competitions where you had this thing called No Hands Across America. The big difference between then and now is the fact that at that time, that competition involved traveling long distance on the highways in the US. Whereas today, the self-driving cars are focusing on city traffic. What's the big difference between the two? In the case of that old one, you didn't have to worry about pedestrians and such things or people doing all sorts of crazy things on the highways. At least in the US, the highways have a lot more discipline than what you might find in the highways in India, where you still find people going in the wrong direction and all that. Or you even have pedestrian crossings even in the national highways. Whereas now, in the city traffic and such kind of environments, life is a lot more difficult, and that's what makes the modern day work on self-driving cars. And the other thing, of course, is how do you deal with situation where you know that there is a problem? Either you have to turn left or right, and turning left might cause a child to die. Turning right might cause 10 adults to die. Who makes the call when that algorithm is being written? Which is more valuable? Should you say, hey, this child should see the world and live a long time? It's okay if these 10 guys who have had a good life, so maybe not good life, but they've lived for long enough. So there are these kinds of ethical questions that have come up now. So this is where, of course, lawsuits and all that are also a factor. Depending on which country you are in and things like that, the person who writes the algorithm or the company that's behind the algorithm might get sued if somebody dies because of whatever the choice was that was made. And so, in many such ways, for such reasons also, there are many people who now interpret the acronym AI not as artificial intelligence, but more as augmented intelligence. The idea being that these systems and these algorithms and all that are intended to help humans do a better job or do a more informed kind of decision making, rather than completely replacing the humans and taking over their jobs and such things. Partly also because of these, what is not clear in a certain situation as to which choice to make, because it's not such a black and white kind of thing. In any case, there's quite a lot of stuff that's gone on, and IBM Deep Blue was the first time when the system defeated the world's expert on chess playing, right? This is the Garry Kasparov thing that happened around the time I became a fellow. So it was like 95 or 96, I think, is when that major development happened. So now fast forwarding to the current era, in that Shanghai event, I heard actually a presentation by Chi Lu, who at the time was the CEO of Baidu, and I didn't even know at the time that Baidu was doing more than what I thought it was doing, as like, the China equivalent of some of the US social media kind of companies, but that it was also developing its own operating system for a self-driving car and a huge ecosystem and things like that. And this happened to be soon after the once in 5 years Communist Party Congress and all that. So a bunch of government kind of officials, as well as the Chinese Academy of Engineering and so on, people gave presentations. And the message there was that China now feels that in this era, China has the wherewithal and the data and such, with the billion-plus population and the Chinese equivalents of Facebook, LinkedIn, Amazon, and so on, that the information that they have gathered, Baidu, Alibaba, and such, Tencent, what they have got, even based on the Chinese population, is numbers-wise much bigger, but also in terms of the applicability of that kind of information about buying patterns, whatever, right, that they have tracked, they would be more applicable also to countries like India and many countries in Africa and so on, given the affordability and the kinds of homes that people live in and so on, which are very different from what the Western companies might have with their population, okay? So for such reasons, the belief is that they could now try to do one-upmanship on the Western countries' companies in this space. So this is being viewed in a very serious way by many people as something that needs to be taken seriously, and not take it in a very casual way just because something is being done in English. That necessarily means that it will be the winning thing or whatever, right? There's way too much stuff that goes on in my backyard in Silicon Valley, where I've lived 38 years, where people think that whatever they happen to be doing there is what the whole world is going to adopt and things like that. But impact of AI is going to be everywhere, not anymore in any niche kind of areas. And that's where I was saying that even inside database systems and such, people are now trying to leverage ideas from AI to make the internals work better, or the externals be easier to deal with for database administrators and system admins and so on, because the systems can be more self-managing and things like that. And so there's also this distinction being made between general AI versus AI for a specific domain, and we'll get into some of this discussion a bit later. The other thing that he talked about, which I don't think I'm going to deal with because I'm probably not going to have enough time, I'll make available in a few days this slide set, and so you can go look at it yourself. In terms of the topics, going back to this IIT conference, it's huge now. This is just like a high-level summary. It's not session topics, because there are so many sessions and so many workshops and tutorials and all that. thousands and thousands of people attend this conference now. I actually saw the inauguration of this in 2007 or 2008. I don't know if you remember. It was held in Hyderabad. 7. For the first time, the International Convention Center that they had built was used for HKI. But the inauguration happened in IIT Hyderabad, and I happened to be there. And interestingly enough, Raj Reddy was there too. So there is now these sorts of topics being focused on planning and scheduling, uncertainty in AI, constraints and satisfaction, heuristic search, game playing. So there are certain things that you'll still see are common with the first conference back in '69. This was held in Macau last August. But there are also certain things like more focus on applications, multidisciplinary topics and applications and such. AI for a certain topic in healthcare or something else, manufacturing and such things are being focused on, as well as art and music, for instance, right? So what is now being called deep learning is not really brand new thing. For a while I didn't know, what is this buzz about deep learning? I'm like, is this some really revolutionary new topic? It turns out it's not. It's really a variation on neural nets that have been around since, as it says, 1950s. After a while, it sort of died down, and then it got revived. Why? Because of these newer developments in the area of both availability of training data, vast amounts of it, and also the compute power and such enhancement that had happened in the meantime. So essentially, as I said before, this one doesn't take into account in any systematic way aspects of the world as you would have done with what I call, taking into account syntax and semantics and all that in the case of speech understanding, right? So you feed in, it's famous, as if it's a real world problem that needs to be solved, recognizing cat pictures and so on. So you feed a bunch of pictures which you declare are cat's pictures, and this magical thing happens where many levels are there in this neural net. You can interpret what happens as if what's going on is that the first level is identifying light areas versus dark areas in that picture, that image. Then you are identifying edges. Then you are identifying combinations of edges to see, oh, this might look like an eye, or this might look like an ear, and things like that, right? You then actually say, oh, that area that has something special about it compared to some neighboring things is actually an eye or a ear, and so on. And then you can even look at combinations of features to say, okay, this combination could only be, or most likely be, that of a cat as opposed to that of a dog and such. But this is not like a guaranteed thing in terms of being always accurate. So you feed lots of cats' pictures, and then this configuration happens where different weights get attached to these different nodes and arcs and so on. So that's what that multiple hidden layers process hierarchical features thing that says at the top. So there is the input layer and then there's the output layer. Then once it has been trained enough, then you can feed pictures where you haven't labeled them and ask the network that was produced as a result of that training to identify which of the input pictures are those of cats versus which are not. And there you might then discover that it does make some mistakes. And then you say, hey, you made a mistake here, and that can then fine-tune this network. So it's this kind of magic in a sense where it's really like a black box. You don't know exactly what causes it to conclude something is a cat picture versus something is not a cat picture. And it's not 100% guaranteed to work always. And this is where what I said before about what you use to train might be a question, it's like a garbage in, garbage out kind of thing. If you trained it with one set of things, and then you send in a different set of thing, but at a certain abstraction level, it's the same kind of thing, like human beings, right? You trained it with white people, but later on you send stuff that relates to black people or brown people or whatever, and it might not just do a good job at all, and that's how this, black man's picture got identified as a bear's picture, right? So we talk about ways of knowing, the neural lens way of doing it versus the symbolic lens. In the symbolic lens, when you are trying to identify an apple, you describe what an apple is. You talk about where it comes from, what the structure is, what kind of thing it is. It's a fruit versus a vegetable, whatever. And talk about apple trees and so on. So what you and I as human beings might, when we are growing up from childhood, get taught by parents or whoever, teachers, as to how to recognize what an apple is, involves more this bottom way of doing things. But that's the one where the belief has been for a long time that it involves more work for the people to develop this whole hierarchy and such, whereas this neural net kind of way is that top kind, okay? So I've already talked about this, how the deep learning explosion came about as a result of 3 different developments: improved algorithms, improved availability of compute power, and also all this vast amounts of training data. It turns out it's not like in all areas you have vast amounts of training data, and that's where you run into problems when you go beyond all the silly, identifying cat pictures and such to, in a practical sense, useful kinds of domains where you want to solve problems. You might not have enough of the training data, and it's especially true of enterprise kind of context as opposed to social media kind of context where you don't have enough of the training data. And so that's where there is a lot of focus going forward on trying to figure out how with small amount of training data you can still try to do some of the things that people have done with vast amounts of training data and so on. Turns out, at least in the ImageNet classification world, by about 2015, the system became better than humans in terms of the percentage of errors in wrongly classifying the images. So we have gotten to a stage where the system is doing better than humans. So we talk about, in the core AI space, narrow AI to broad AI to general AI. The narrow AI is the one where it operates in the single task, single domain, and that's where there is superhuman accuracy that's come about. Whereas in broad AI, it's across multiple tasks and multiple domains, and that is still, more futuristic kind of space that we are going to be working on this stuff, and essentially for enterprises. And of course, the even longer duration one is the notion of general AI, seamless cross-domain, what you did in one domain being usable in another domain and things like that. So in terms of the narrow AI, the kinds of problems that have been solved have to do with things like language translation, where, for instance, IBM had some real-time translator where troops, the American soldier will be walking on the street trying to communicate with the common man, and so he'll be speaking in a version in real time as a, and then when the person soldier in English and things like that. Speech transcription, of course, has been a lot of companies, even in India and the Caribbean and so on, were the ones to which recordings by doctors dictating what they when a patient came. Then these guys will transcribe it, humans will transcribe it, but now system software is doing a pretty good job of it. But you probably have also seen Google Voice and such giving you, when somebody leaves a voicemail, a language version, written version of what the thing was. And it's not completely foolproof. It does make mistakes. Sometimes it will have blanks where it doesn't know what the actual word was that was mentioned. And of course, this is where accent and everything also becomes a big issue, right? It's not like everybody speaks exactly the same way or, pronounces a certain word the same way and things like that. Language processing, of course, is NLP and such topics. A lot of work goes on in my lab in NLP space, for instance, as well as in other parts of IBM. And then visual recognition, of course, both static images as well as videos and such, identifying, certain objects within a video as the object moves, whether it's a bicyclist or a human walking and so on. You'll see some examples later. You also now need to worry about explainability. Just telling somebody, hey, my algorithm said you are not worthy of being given a loan is not going to be okay, because there are, depending on the country and various regulations, you might be held liable to get sued and such if you are unable to explain why somebody's loan application was denied. You might have heard recently about the co-founder of Apple getting very upset with, I forget now whose credit card. This is Steve Wozniak. He and his wife applied for this credit card, and he got a higher credit limit than she got, even though for all the input information that was given to this credit card company. Sorry? Yeah, that's what I'm trying to say. That they didn't get the same credit limit, even though on paper they both had the same kind of history and so on. And so the big thing that was talked about, this might have been an Apple card or something like that. That was a weird thing. It was one of his own original company's thing. So there are things like that that are coming up. And so you have to be able to say what aspect of this person's past or whatever it is that was the reason as to why the person was denied a loan or was given a certain credit limit when somebody else got a higher credit limit and things like that. The other thing, and also even for you and I as ordinary people, when the doctor says, hey, based on whatever was measured, I think you have cancer, you're not going to be happy. You want to say, hey, what exactly that you saw led you to believe or conclude or suspect that you have cancer? You need to be able to give some rational explanation for why you were led towards at least thinking there's high likelihood it's cancer or whatever, right? The other one is, are these algorithms such that where if somebody tweaks the data that's being input a little bit, could that result in dramatically different conclusions being arrived at? So in other words, if it is actually a stop sign, but in the image of the stop sign, some bits are manipulated, could that be interpreted as go maximum at 15 miles per hour kind of speed limit? And this could result in, if bad people do this, accidents and so on. In context, if you are not being careful, somebody sitting the lights at an intersection in all directions to be simultaneously green, resulting in collisions right in the intersection. That in this day by computers and such, for people not to get into trouble when there are bad elements, whether they are state actors or non-state actors, as you've been, I'm sure, hearing about. And then this whole thing about ethics, are you being fair to the people? Are you based on the zip code where somebody lives, trying to conclude they could be criminals or that they are not credit-worthy people and such things? There are many, many such things that have become important. Even this recent cases where, at least in some US courts, they are using an algorithm to decide what the punishment should be for certain crimes. Are those algorithms being conscious of the ethnicity of the people involved? So are blacks getting longer sentences than white people, for instance? Is that based on some historical information that's actually accurate, or is it a biased set of samples that have been fed? and that's causing this kind of disparity to come about that's not ethical in nature. And the other thing, of course, is transfer learning or being able to take small amounts of training data and still be able to benefit from it. And then, of course, the different kinds of hardware enhancements that are being made that we'll hear about. So, in addition to what you normally would hear about, which is GPUs and FPGAs and all that making a big difference, with various companies in this space producing those sorts of products. Now there is even more focus on trying to deal with the fact that with wider adoption of AI algorithms and the amount of data and such that are involved, the compute requirements are doubling every 3.5 months. This is not like Moore's law and all that, where we talked about every year and a half doubling of the compute power that's available. Here we are talking about the compute requirements being doubled every 3.5 months. So this is unsustainable given the current speed at which, in spite of Moore's law's long-term sustenance being questioned, even if it were to persist for a long time, doubling every year and a half and so on, that still won't be able to handle this kind of major increases in the compute requirements. So there are more details there that I'll let you see offline. So performance and watt gains will be secured using approximate computing. So it's no longer the case that for the sorts of algorithms we are dealing with in this case, you need to have as much accuracy, double precision and so on, that we would have all heard about, those of you that are geeky kind of people, that are computer science or hardware people. It turns out you can reduce precision and as a result be able to deal with more complex things and still have enough accuracy, because absolute accuracy is not so important for a lot of these kinds of algorithms. So it turns out not only is digital technology something that you'll continue to benefit from, but you can also combine analog with digital and leverage that combination in interesting ways, in a hybrid way, to also have major improvements. And there are also new kinds of materials being dreamt up, as well as existing materials or technologies that are being put to use in different ways. One example being, for instance, byte addressable non-volatile memory, phase change memory and such, that have been used to turn essentially DRAM to something that used to happen before. When I was a student here, we had core memory in the IBM 370, 155 here. Even if the power goes off, the values that were in the memory will persist. But with DRAM, which was invented by one of my colleagues in T.J. Watson Research Center, Bob Dennard, if you turn off the power, the memory contents disappear, okay? But now there is this work which is in effect changing what SSDs do, which are page addressable, and it has also some other bad properties. I can spend a lot of time talking about those things. There is this, more recently, Intel has provided this byte addressable non-volatile memory. So some of the circuitry that's in the memory to deal with this byte addressability turns out can be used to also push some of the computations that happen in a matrix multiplication kinds of algorithms that get executed in this deep learning arena into the memory, so that you don't have to drag the data into CPU in order to do some aggregation of the data and things like that. So this way you can also get more parallelism and such. So in this context, we have this AI hardware center where a lot of these sorts of things are being done. And so here you see that there's a URL, and you can offline go look at it and see what are some of the things that are being done, where you are going from traditional digital, more precise kind of computation to then doing approximate computing. And they've been able to reduce from 8 bits to 4 bits and things like that, the precision, and still provide fair amount of accuracy, but at the same time deal with vaster amounts of data and so on. So there are more details here that I won't dwell on, and this is talking about eliminating the one-Neumann bottleneck and also making use of that non-volatile memory stuff that I was talking about earlier by pushing some computation into the circuitry that's there in the memory to be able to, modify cache line worth of data in a persistent way and such to also do some computation in the memory. Am I running out of time? Okay, 5 minutes. So there are many things like that that you see here being talked about, objects being recognized, entities being recognized, face recognition where a basketball player or whatever, as he's moving around in the court, dribbling the ball and so on, being able to keep track of a particular person that you are interested in and such. And as well as natural language processing and parts of speech being recognized or higher level concepts being recognized and things like that. So AI for the enterprise has to do with going from narrow to broad AI, as well as operationalizing AI at scale. What might work in your lab and so on, can you make it work at the kind of scale that I was mentioning before that guys like Srinivas Narayan are dealing with at Facebook and so on? How well are you able to do that? And there's also this business of where we are today and where we would like to be in the future in terms of going from narrow AI to broad AI. What are the different kinds of things that need to be addressed at different levels, from the data level to the compute level to the algorithm level, and also in the application space. It's fairly self-describing kinds of things that you can read about and go from static data to dynamic data, or train and deploy versus continuously learn and adapt. So these are some of the ways in which you can make your algorithms change over time without you are having to shut down the system and shove in a new set of algorithms and so on, which is what for the most part you have to do now. It's not as adept at adapting, if you like. Oh, what happened? Okay. So there are all these things that I've already sort of talked about: fairness and explainability, adversarial robustness. That's the one where the stop sign is being made to look like it's a 15-mile speed limit kind of thing. And also transparency. Can you now publish the details in a way where somebody that's interested in knowing what are the different aspects that are being looked at when somebody applies for a loan, that goes into deciding whether the person gets a loan or not, and if even some additional collateral is needed and such, under what conditions, what kind of collateral must be provided before the loan gets approved and things like that. This is also to avoid, in places where a lot of bribery is involved and such things, where we say there is no transparency as to why somebody got something. Now, in a more algorithmic sense, being able to let ordinary people, as opposed to geeks, even the geeks might not have an idea as to how this whole thing is working, but even ordinary people especially, can they have trust in the system doing the thing in a transparent way and not being partial to one kind of people versus another kind of people and things like that. And this is the one about AI for AI, meaning even inside the AI systems, leveraging some of the AI ideas. It's somewhat like the thing I said about database systems not having a hardwired cost model, but instead, over time, building up the different attributes of the cost model by observing what happens. If I use the index, this is the amount of time that's taken to process this query versus if I do a relation scan. Instead of making the builders of such systems do the work themselves to figure out what the cost of going this way is versus that way in an algorithmic sense within the database system on how you process the query. The other thing that's happened is that you might have heard about the Jeopardy system, which, the IBM developed the system that beat the two best humans in the game of Jeopardy. This happened a while ago. But the more recent thing that many of my colleagues have worked on, especially in IBM Haifa lab with other partners in the rest of the world, has to do with making the system take part in debates. This is a much more complicated situation compared to how the Jeopardy thing worked, where it was essentially like question answering, you know. And also the system didn't have live access to the internet. All the information that might be asked about was preloaded and organized in certain ways and all that. But as the competition was taking place, there was no interactivity. Even the questions were typed for the system as opposed to the system doing speech understanding and so on. Whereas here, there's a lot of back and forth that goes on. And the software can be told to take the pro position to the proposition or the opposite position. And then it has to come up with cogent arguments. And also, as the other parties that are taking the counter position argue that the system is messed up, that its logic is flawed and all that, it has to understand what they are saying and then come up with counter arguments. And so it's like acting like a human being. And it's as if this whole thing is being done by a human and not a machine in a very staccato kind of fashion coming up with things. So there's fair amount of complexity involved. And the jury is still out on how well the system has performed. I think it is won in one case and lost in another case and all that. I've forgotten now the different things that happened in, I think it was in San Francisco where we had the competition, and the main person behind the whole project from Haifa, she came to my lab and gave a talk. But this is a pretty interesting situation where many aspects that go into AI have had to be brought together. Rebuttal and all this kind of stuff. Various and other kinds of institutions. You even see IIT Delhi there, as well as MIT. And so there's more trying to put together all the things that I briefly talked about: narrow AI, broad AI, and general AI. Advancing core AI, trusting AI through these various aspects, and also scaling it for different domains or different volumes and so on. And if you want to follow some of the things that I'm doing in not just this area, but even blockchain and databases, there are some of these things that you can look at. Thank you.
Good evening, sir. My name is Suresh Malia. I'm a layman to your technocrat inputs, but my common sense logical question is, applying this concept, is there any work is going on or is going to be started for the benefit of the target segment of deaf and dumb? For an example, I'm applying the logic when the news is read, somebody is using the sign language to make it easier for them. So that this is applied here, it will make their learning and development much better. They would be more inclusive.
Many of the ideas from what I even said, things like identifying humans in the game and so on, and following a particular human, those sorts of things could even be used to help the kind of people you are referring to. Instead of using sign language, if they are able to read, for instance, transcription of what's being spoken, just like all the subtitles you see even in CNN and such things, right? When humans are talking, they, for some things, do closed captioning, right? Those are areas where, yeah, you can, by leveraging AI-ish technologies, NLP and such, combination of spoken as well as potentially written stuff, you can make such people benefit.
So my name is Raghutam Rao. I head the Gopal Krishna Deshpande Center here at IIT.
Okay.
So my question really is AI being held to a higher level of performance by regulation and laws than human beings, in whether it's medical or judgment or automobiles or whatever that be? And is it fair?
Yeah, in fact, that makes me think of a couple of things I wanted to say. I didn't get around to putting them in the slides. One is this Itihasa effort, this non-profit that Chris Gopalakrishnan started. They now have a report And in fact, Ravindran here has been interviewed as part of that report's preparation, which was an attempt a year and a half ago, I think, right? About a year ago, to summarize the AI/machine learning research that's going on in India, where it fits in the rest of the world and so on. That's one of the things that would be a good thing for you guys to look at. In terms of what you asked, the other thing that's sort of relevant to this thing that I wanted to mention, which I forgot to do before, is this sort of a manifesto that IBM guys put out maybe 2-3 years ago, trying to say what are the important things that one need to think about. This is like, for instance, when cloning was a big topic, people said, hey, you shouldn't clone humans. It's okay to be cloning sheep and this and that, because they thought there were a lot of ethics involved here, and so we should stay away from even things like identifying the sex of the baby, especially in countries where people prefer, boys versus girls and so on, which leads to, abortions and such. There are many things like that that come into play. But the particular thing that you raised is something where the concern is that with humans, the scale of, if you want, damage that could be done by a bad human might be much smaller than what an algorithm could do. So to that extent, you do want to potentially apply stricter standards on to the algorithms than, I'm not saying you should not let the humans also go through more rigorous kind of way of examining their activities. It's just that the reason you might be seeing more focus on the algorithms and such systems way of doing things as opposed to human way might have to do with what is the extent to which damage could be caused by something that can have broader impact and quicker impact and intensity of impact and such things.
You're saying it should be hand to hand.
Yeah, because of the fact that it can be more pervasive and more immediate and so on, compared to a bad human being let loose on the world, if you like.
Sir, my question is about that the IBM is working on the quantum computing.
Right.
And after 50 years around, when the computing power will increase enormously, then when it combined with the AI, can it lead to the disaster for the humans?
These are the sorts of things that are being debated all over the place. In fact, on a more positive side of things, I didn't mention explicitly, but I think in one of the pictures, IBM's system Q was shown as something that the extraordinary compute power capabilities that might be available in the near future, as opposed to the kind of time frame you mentioned, could make a huge difference with respect to the kinds of problems that could be dealt with compared to traditional computers being used. But in terms of whether quantum, for example, could potentially cause many of the cryptographic algorithms to break, that is something that I'm seriously worried about and being worked on. I don't know how many of you know about the SHA-128 versus 256, right? Or there are examples where people have been able to break certain things because SHA-128 was found to be, easily compromised, right? So that's why they are recommending now SHA-256. So there are things like that that are being worried about, even in the blockchain area and in general in cryptography and so on. If you want to do things anonymously or transfer information without anybody being able to tap on it and figure out what's going on and so on. So, but in general, there's a lot of discussion along the lines that you are hinting at, which has to do with will people lose jobs and things like that. So even in the Bangalore Tech Summit that I was invited to speak at in November, there was even a panel discussion on what are the skills that will be needed for people whether humans might lose a lot of jobs because these systems can take over doing a lot of the mundane jobs that humans might be doing and things like that, or will open up other kinds of jobs, but then people who are not so skilled, the fact that it will open up fancy, algorithmic kind of jobs is not satisfactory, right? Because they are not in the same space to be able to do those sorts of jobs. So retraining such people to even work on what might open up as newer opportunities is not something that can be done trivially. Any other?
Good
Okay.
evening.
Oh,
If you don't mind.
it's been going
Yeah, it's been.
so
it's
let's,
kind of
sure.
confused. Okay, just one question. AI, as even you've mentioned in your slide, has been used a lot in many domains, even more now recently. So, which domains do you probably think would be more influenced as compared to the others? Any idea?
I think that's a hard question to answer. If you look at, for instance, as I pointed to the Vadvani AI Center and so on, they are focusing on what are being thought of as for social good, right? But there are others who might be working on things where they do want to make money. And so, who is willing to pay for certain things, changes from country to country and even within a country. There are some people, including my son, who thinks that he should work on government tech, civic technologies, rather than going and working for regular commercial kind of software companies. And I try to tell him it's not always black and white, that one kind of work is superior because it somehow is more of value to society and so on. Everything has its plus as well as minus. Social media has a lot of plus things too. It's not all frivolous stuff. The Spring Revolution and all that, a lot of it is attributed to Facebook, right? So in that, I can't give you this is what is more important than that and so on, because a lot of it depends on where you're going to apply it and whether you are the good guy who's applying it versus bad guy, and what your motivation is for doing certain things. So, yeah.
Hi. This question is actually about Jeopardy that you referred
Mm-hmm.
to. I remember watching that, and when it beat the two players, Ken Jennings and Brad Rutter, could you comment on that? And my quick second question is, since you mentioned Shah, has to do with that n bit in the compression function, the weakness that you're referring
I
to?
myself am not an expert in it.
Yeah.
There are now algorithmic ways of generating, given the hash value, two different versions of, I think it's a PDF file or something, that both come out with this, something like that is what is there. So with respect to the first one, there is no magic as such, right? This is no different from that, I talked about this before. This muffin being recognized as some animal, I've forgotten what that animal is. That happens. So I believe the big one that you might be thinking of is, it thought of an airport. Yeah, I know the one you're thinking of. See, what it tried to do was, if something passes beyond a certain probability of being the answer, it just said, okay, let me take a risk and think of that as an acceptable answer to give. There was this notion of confidence level associated with the different potential answers that it was able to support with some information it found in whatever was there. The fact that it relied on that information, which was, as I said, preloaded, as opposed to in cases like debater. One of the interesting things that I had not thought about, but when this IBMer from Haifa came and gave the talk in Almaden, they had to even make calls like what is now very, much of a hot topic, which is fake news. What sources of information should you treat as trustworthy sources versus flaky ones? Because when this debater is trying to come up with arguments to support whatever the position is it's taking, can it give equal importance to everything that it finds on the web? Just because something is on the web, is it true? Something has been published. I mean, you've heard about all this, I'm sure, right? So it's those sorts of things where you have to, like people's reputation being taken into account. When you say, hey, this hotel is a good hotel versus that one, am I going to take it at face value, or I want to know, hey, on what basis are you making this assertion? Give me the reason why you think that way. Have you stayed 10 times here and just one time there, or you stayed in both hotels 10 times? So things like that is what makes life complicated. And so there is no easy way of dealing with these things. And so, they'll talk about, oh, if something was published in New York Times, maybe it's more trustworthy than some flaky newspaper, right? Things like that. But it still involves a lot of, subjective judgment and things like that. So who is the one that determines what the set of sources are that are, even Wikipedia, as many of you know, I'm sure, people go and do something, and for a moment, it might contain something that's completely wrong until somebody else comes and fixes it or whatever, right? So,
two quick questions,
yeah.
sir. First, you gave us enough instances of human prejudices, religious, racial biases getting transferred to AI algorithms.
Based on whatever was the training data, yes, and so on, garbage in, garbage out.
Exactly. So how, do we have any regulatory framework, mechanism? He talked about that, but do we really have any regulatory framework or any standards?
See, those are the sort of things that I'm sure you've heard the testimony by Zuckerberg in Congress and how he got grilled and all that, even in the context of the Libra currency and so on, right? So, depending on the country and such, whether they proactively do something or wait till things happen and then they take corrective action, there is no coordinated effort, if you like. One of the things I actually wanted to talk about also, and I didn't get around to saying it, different countries have come up with policy documents on AI, for instance. I believe even in India, they've done something in this space. Definitely France and a whole load of countries have tried to come up with national level policies on AI and what to do and what is going to be thought of as acceptable use of AI and what not and so on. So these are the sorts of things, just like with Airbnb and Uber and Ola and so on, a lot of the regulatory things didn't exist to deal with these things because the laws are so old that they didn't know that the world will evolve in a certain way in terms of technology and so on.
Sorry, I just wanted to add to that, right? So the national level policy just about what sectors we want to use AI in and so on and so forth. But the Tamil Nadu government has come out with a draft ethical use of AI policy. And I believe that's the first such effort in the country, possibly around the globe as well.
In fact, it's good you reminded me this. I'm now an honorary advisor for the Tamil Nadu e-governance agency, and I was in fact yesterday there. This came up and I told the guys, hey, I need to make sure I mention it during this talk, and I forgot. Thanks for bringing it up, Ravi. I've even forgotten what the acronym was, DAP something, DAP Max or something. Anyway, there's some stuff that is being worked on. So really it all depends on also who is interested in having such things, because there are some people who would be happier leaving the way things are because that gives them the flexibility to do some hanky-panky, which with the use of algorithmic way of doing things, they might not be able to easily get away. This includes even stuff being done in a very carefully tracked fashion using blockchain versus humans doing it. Because while humans could maybe, do a better job or at least carefully think about consequences in a way that is not easily codifiable as algorithms, it's also the case that they could also misuse things, right? So there isn't a clear-cut it's not easy to come up with really fixed set of things. Some of the laws of the land evolve based on what happens and so on. So I'm sure you are aware that in certain countries or even certain specific cities within countries, they banned or even Airbnb for that. Uber is not there or Airbnb is not. Even in San Francisco, there's a lot of chaos in terms of traffic based on lots of these vehicles moving around and things like that, where they are not parking the vehicle because they are looking to see when offices are closing, whether they can pick up passengers and so on. So it's not trivial really as to how to deal with these things. And you can imagine now the people who are not tech savvy, like people in legislatures and so on, trying to deal with some of these things. And if you and I as geek people cannot talk to them at a level where we don't keep using our computer sciencey, algorithmic or acronyms and so on, that makes it so much harder. And that's true of even judges and so on, right?
One more quick this thing. So one of the tendency that happens in India recently is like whenever you come up with an emerging technology or scientific area, they usually say we already have it in our Vedas and Puranas. So I'm just trying to understand, is there anything really there that exists in our this thing?
That I don't know. I wouldn't even. By the way, I should have prefaced everything I said by saying, even though I'm an IBMer, I'm speaking here as Mohan the individual, not as an IBM, executive or whatever, because there are lots of things where press people might misinterpret something. Some IBM senior guy came and said blah blah blah. So I'm here more as an individual speaking about things. So don't take anything that I say as IBM position or whatever.
We'll take two more questions.
Okay.
Good evening, sir. So one aspect I want to inquire about recent approach of AI related to how exactly the learning mechanism happens in an infant child. How exactly a child learns. Basically, a few-month infant whose mind is not much developed. So based on limited information, he generalizes or he developed new ideas, generate explanations which no one teaches him. So they are said to possess predefined knowledge, domain-specific knowledge in various domains. So after interacting with environment, they try to generate novel explanation and ideas. So based on intuition, so as he connects with ancient ideas of Vedic scriptures, so the term that comes is consciousness. With respect to consciousness, how exactly the learning happens in a child and any computational aspect of it, the recent attempt that can be made that systems can generalize to more better information.
Okay, so this actually brings up a related thing which has to do with brain research and so on. The other report that the Itihasa guys have produced is the state of brain research in India, and I'm sure you are aware that Chris, in particular, Chris Gopalakrishnan has funded a couple of chairs or something in IIT Madras as well as at IISc, or 3 chairs, is it? And also in my own lab in San Jose, in Alameda Research, we have Dharmendra Moda, who has been leading for quite a few years now, a brain modeling project, neuromorphic computing and so on. He and his people have even developed special purpose chips that mimic the way the brain works. It's not computationally, in terms of power, and the instruction set and so on, it's not very sophisticated, but the goal there was more to make the energy consumption be low enough that you can exploit parallelism for certain kinds of algorithms. So in doing all this, they are trying to, move up what they consider to be the stack, which is like mouse brain followed by, cat brain, this, that. There's some hierarchy. So as part of all that, they are trying to model in software and even special purpose hardware how the synapses and such in the brain morph over time and so on. So that has to do a little bit, at least, if not completely, to do with the sorts of things that you are talking about. But I don't think, anybody would declare that they know exactly how what you talked about in the real world happens, in the sense of how you and I, when we were growing up, figured out how to recognize this, that, and how do you know who's your parent and so on, as well as other things in the world.
Good evening, sir. Interesting talk on AI.
Thank you.
Giving a perspective of what is happening. So my question, or can I make
You should hold it closer. Yeah.
So the thing is, there are like so many people working on AI and deep learning and stuff, but we are constrained by the budget of the total power that we can actually produce and then consume. So if you see, most of the companies that are set up are close to places like Yoshua's place is close to the perennial river that is there, that's running, like, such that they can produce energy and do their computation. So do we need to pick and choose our problem like wisely, or I kind of give some intelligence to AI such that you can leap further without using too much of power? Because the current state of algorithm is like you just throw the problem at it and people are just generating results. So
I get what you're trying to say. That's partly why I was saying this AI hardware center and such are trying to change the traditional way of doing business to try to with the same amount of, if you like, compute power, do more by, for instance, reducing the accuracy and things like that. And this also relates to what I just said about the work that's being done in the what used to be called Synapse project in Almaden, about which lots of papers have been written and things like that. It was not just IBM. IBM was the prime investigator, but it involved a lot of universities and even national labs. And there is a similar project called the Human Brain in Europe, which originated at EPFL. So there the goal was to, as I said, consume a lot less power, because it turns out the human brain actually consumes very little. How you measure it, I don't know, but if you think of it like power, electricity in the context of computers, and so the attempt that these guys have made, I've forgotten now what the chip is called, it has limited instruction set, the kinds of computations it can do, but it will do it a lot more efficiently in terms of power consumption as well as the heat it generates. So the cooling and all that wouldn't be as much of a problem as it is these days with some of the highly powerful single process kinds of chips. So it's also the case that there's a lot of wastage of energy that's being done by blockchain people, right? With all this proof of work and all this silly stuff that I don't believe in. I'm more of a permission blockchain guy than all this cryptocurrency with permissionless. So they, for instance, do the sorts of things that you're talking about, going to places where energy is available cheaply and so on. So, but in general, the core design of hardware and software that Pratyut was talking about earlier with me are the sorts of things that are being done with this AI hardware center and such, where they are saying, if you really want to make use of systems to deal with larger scale problems and such, or doing things at a finer granularity, then you need to have this compute power available that is not there in today's way of doing business with von Neumann computers and so on, or purely digital technology. So I think this is one of those situations where it might be like beggars can't be choosers, right? You might have a lot of ambition, but if you can't provide the appropriate compute power or whatever it is, you can't solve certain problems. And so in terms of choosing problems, what I had this discussion earlier, it's not enough for people, whether it's IIT Madras or wherever, to just work on algorithms and write papers and think that you've done something great. You also want to have real world impact, and so you do need to build software, make it available for others, and how we measure impact, we get harassed at the end of every year what have you done lately? And, just saying I wrote this many papers and so on is not good enough. Did anybody care that you wrote those papers merely because it got accepted at HKI or AAAI or whatever? That by itself, even if it wins awards, but beyond that, nothing in a long-term sense happens with it. This is not too different from somebody might have developed a product, but hardly anybody bought it, or somebody wrote a book, but it's just sitting, somewhere in shelves and nobody is even reading those books. So there are various ways in which you can, measure the value of some work and so on. So I would like to see more practical orientation, and the particular thing that I was also talking about was how much of collaboration is there between professors themselves. Is it always just one professor and underlings, and it's a strict hierarchy? If you look at Berkeley and Stanford and various places, MIT, there's so much collaboration across professors themselves, across different people and their PhD students, and that's where you will have greater level of impact than 1Z kind of professor and assistants and such working on something.
You see, without understanding the notion of self and living instinct, can we ever define intelligence?
Oh my God. I think this is too high funda.
We'll leave it.
I don't think I'm going to get into this kind of discussion. I'm not one of these, what do they call them? Yeah, gurus and such. I don't want to mention any specific names, but I'll stay away from. I consider myself to be one of these nuts and bolts kind of guy. By the way, all my life I've been a non-manager, 38 years of my technical career, and working only for one company. So for me, a lot of this higher level stuff, of course, some people accuse me of not having emotional intelligence and all that, and I don't care. I'm a really details-oriented nuts and bolts guy. So some of these sorts of things, I think we have to wait and see what happens. Of course, there's been a lot of hype over the decades on what AI is going to do and so on, and it didn't live up to a lot of those expectations over the decades. But whether, it'll ever become better than humans in terms of quote unquote, whatever the, a very precise way of defining intelligence might be, remains to be seen.
Thank you for your insightful talk. I'm sure that the knowledge you have imparted and the ideas you have shared have left a lasting impact on our audience. As a mark of our gratitude, may I request Professor Ravindran from the Department of Computer Science, please set the speaker with a momentum. May I now request you, sir, kindly leave us a message in the EML yearbook. We wish to express our heartfelt gratitude to Dr. C. Mohan for his presence here with us today. I take this opportunity to thank all of you who have rendered their unfailing support to us in organizing this session successfully. Last but not least, a big thank you to the audience, without whose presence, the session would not have been meaningful.